When a gas is kept at constant temperature, its pressure is inversely proportional to its volume. So by inversely proportional here we mean that the pressure is equal to a constant divided by the volume. So the pressure is proportional to 1 over the volume. And in symbol form, that is P is proportional to 1 over V. So that means that if the pressure doubles, the volume will halve. Let's have a look at a way we can rewrite this equation to make it more useful for solving problems. The product of the pressure and volume of a gas is constant. So this is another way of defining inverse proportionality. So the pressure multiplied by the volume is equal to a constant. And in symbol form, that is P times V is equal to a constant. So for a system at a certain temperature, the product of the pressure and the volume will always be the same. This leads to another equation, where P1 times V1 equals P2 times V2. And this simply means the product of the pressure and the volume before is equal to the product of the pressure and the volume afterwards. So 1 refers to before and 2 refers to after. So in this equation, the pressure can be measured in pascals and the volume can be measured in meters cubed. But in reality, we can use any units as long as the pressures and the volumes match before and after. For your exam, you will need to be able to identify when to use the P2V2 equation and when to use the constant. Let's have a look at an example using these equations. A piston is used to compress 8 times 10 to the 2 meters cubed of a gas to a volume of 5 times 10 to the 2 meters cubed with no change in temperature. After the compression, the pressure of the gas is 6 times 10 to the 5 pascals. Calculate the pressure of the gas before its compression. So for step 1, let's list the key information and check the units. So V1 is equal to 8 times 10 to the 2 meters cubed. V2 is equal to 5 times 10 to the 2 meters cubed. And P2 is equal to 6 times 10 to the 5 pascals. And we want to calculate P1. So remember that the 1s refer to before the compression and 2s refer to after the compression. So for step 2, let's rearrange the pressure-volume equation to make the initial pressure the subject. So we use this form of the equation as it's easiest to work with and substitute into. We need to rearrange this algebraically and we can't use a formula triangle here. So we can do this by dividing both sides of the equation by V1. Rearranging the proportionality formula is a very popular way of examining this topic. So P1 is equal to P2 times V2 divided by V1. So for step 3, let's substitute in the values to find the initial pressure. That becomes P1 is equal to 6 times 10 to the 5 pascals multiplied by 5 times 10 to the 2 meters cubed divided by 8 times 10 to the 3 meters cubed. And that gives us 3.75 times 10 to the 6 pascals of pressure before the compression.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!